So we have just been taking a look at the function f at x equals 1 over x. And we figured out that the graph of this function looks something like this. Then we figured out that there were two asymptotes in this question. There was a horizontal asymptote of y equals 0, and then there was a vertical asymptote of x equals 0. And then we talked about the limit as x tends to positive infinity of this function, and the limit as x tends to negative infinity of this function. And we figured out that as x tends to positive infinity means that we're way over here on this end of the graph. So what is our function doing? Well, it's starting up here and it's coming down like this. What is the number that this curve is tending towards? Well, it's tending towards the value of 0. And if we looked at the limit as x tends to negative infinity is over here on this other side of the graph. What is our function doing as we make x closer and closer to negative infinity? Well, it's starting down here and it's coming up like this. It's heading towards 0, but it's never going to quite reach it. So again, that limit is 0. And this is what a horizontal asymptote really is. It's a limiting value for our function. Our function gets closer and closer and closer to that value, but never actually reaches it. Now, these two limits are going to be very important for us, okay? So the limit as x tends to positive infinity of 1 over x, we can imagine making x bigger and bigger and bigger and bigger in the denominator there. If we've got a small number 1 divided by something really, really big, you're going to end up with something small. And if you make x as big as it can possibly be, you're going to approach, soon you're going to be dividing a small number by something that's so big that you're going to get something that is really, really close to 0. Okay? So we're going to use this fact to be able to figure out the limits of rational functions at infinity, or the equations of horizontal asymptotes. So we've got these two functions here. I'm just going to move these down a little bit. Okay. And if I want to find the equation of the horizontal asymptotes, what I'm interested in is what happens to this function when x gets very, very big or very, very small. So I want to evaluate the limit as x tends to infinity of my function. In this case, 3 minus 2x all divided by 3x. How do I evaluate this limit? Well, what we're going to do is we're going to follow the same procedure every time. We are going to look at our function, and we are going to divide each term in our function by the highest power of x that we see in that function. So we look at our function, 3 minus 2x divided by 3x. The highest power of x that we see is just x itself. So let's take each term in there and divide it by x. We're going to get 3 over x minus 2x over x divided by 3x over x. Now, this simplifies a little bit. We can change this to the limit as x tends to infinity of 3 over x, because 2x divided by x is just going to be 2, and 3x divided by x is just going to be 3. And now we can actually take the limit, or evaluate the limit, as x goes to infinity of each one of these terms separately. Okay. So take the limit of each terms. Probably just have a no s on the end there. So we're taking the limit of each term. Well, the constant terms are easy because as we change the value of x, as we make x tend towards negative infinity, if we've just got a -2, that's going to stay as a -2. It's not going to change if we change x. Same thing with our 3 down here. If I change the value of x, 3 is a constant, so it's not going to change. But what's going to happen to 3 divided by x as I make x go to infinity? Well, it's going to behave just like 1 over x did, because we're dividing by a larger and larger number. It's going to tend towards 0, right? And the limit of any function that is some number divided by x, or x squared, or x cubed, the limit of that as x goes to infinity is going to be 0. So the limit of our whole function is 0 minus 2, or -2, over 3. So as x goes to infinity, our function tends towards a value of -2 over 3. That's the equation of our horizontal asymptote. Y equals -2 over 3. Okay, that's the value that our function is going to tend towards out at the edges of our graph there. So let's take a look at one more example here. Okay. I've got f at x equals 5 minus 2x cubed divided by x squared minus 4x all squared. Again, if I want to find the horizontal asymptote here, I am going to take the limit as x tends to infinity of this function. For this one, I'm going to expand out that bracket in the denominator. It's going to make it a little bit easier. So x squared times x squared is x to the power 4 minus, I think I get 8x cubed here, plus 16x squared. To evaluate this limit, I'm going to divide everything by the highest power of x that I see. What's the highest power of x that I see now that I've expanded this? Ryan, what's the highest power of x? X to the power of 4. So we're going to take each term here, divide it by x to the power of 4. 5 over x to the power of 4 minus 2x cubed over x to the power of 4 divided by x to the power of 4. Clean that up a little bit. It looked like I had a negative sign there. So x to the power of 4 divided by x to the power of 4. 8x cubed divided by x to the power of 4 plus 16x squared divided by x to the power of 4. Well, let's see if we can do some canceling here. We're still doing the limit as x tends to infinity. 5 over x to the 4, I can't do anything there. But 2x cubed over x to the 4 can become 2 over x. Down in my denominator, I'm going to have x to the power of 4 divided by x to the power of 4 is just 1, minus 8 over x plus 16 over x squared. And now I can evaluate my limit. As x goes to infinity, any of these terms that has an x on the bottom, down in the denominator, is just going to go to 0. Okay, because I'm dividing by something that's getting bigger and bigger and bigger. Okay, and it's going to tend towards 0. So this term is going to tend towards 0. This term will tend towards 0. This term will tend towards 0. This term will tend towards 0. Okay, and what I'm left with is 0. I was working in blue. 0 divided by 1. Can I do 0 divided by 1? Okay, half of you said no and half of you said yes. 0 divided by 1? Yes. You can divide 0 by 1. You're just going to get 0. Okay? So our horizontal asymptote here is going to be y equals 0. Now, what if I'll do this in red. This is if this had worked out to be 1 divided by 0. Can I do 1 divided by 0? Now everybody's shaking their head no. Yeah, you can't do that. This does not exist. So if you ended up with something like that where you're dividing by 0, you would say that there was no horizontal asymptote. And there we are.